Hello everyone. Today I'll be presenting our EAS 550 final project. So this project demonstrates a complete data engineering pipeline using Python, PostgreSQL, DBT, Streamlit, Neon, Render, and GitHub Actions. So I'm going to give a demo of this project from end to end. So with the help of the code space, we have implemented this projects, and you can see the project structure over here, the data, the DBT, and the the queries and Streamlit app, which is the UI, and the ingest data Python file, and you can see the schema SQL and the the security SQL and SQL fluff as well over here. So our pipeline starts with the raw CSV data sets, which are processed using a Python ETL pipeline that is being loaded into the Neon PostgreSQL database. We then use this DBT for the analytics and transformations, and finally visualize that insights into the Streamlit dashboard deployed on the render. So from the data set that contains the customers, orders, products, payments, sellers, and customer reviews that allow us to analyze the revenue trends, seller performance, and delivery efficiency, and even the customer satisfaction. So we use this data set, and we configure the we designed and normalized the relational schema in 3NF using the primary keys and foreign keys to maintain the referential integrity and between the customers, orders, products, and sellers. So going with the ingest data Python file where we build the ETL pipeline using the pandas and SQLAlchemy to clean the CSV data set and transform and load the raw CSV data into the PostgreSQL in the correct relation order. Um, we have already been loaded into the previous phases. So with that, this Neon console is filled with the updated databases from the uh, Python Python file. So if we see, these are the tables of the Neon console. So if you take an any SQL query and then run with the editor, you just have the output over here that tells that just tells the count of the order here. So with this, the process data is now stored inside a cloud hosted PostgreSQL database. So going with the the DBT, so the DBT and the tran you know run and test. So we use DBT to transform the transactional schema into a star schema as requested, optimized for the analytics, and implemented the automated data quality testing. So we have the advanced SQL queries, mm, which is being implemented using CTEs, aggregations, and window functions to just generate the business sides. With this insights, we have our live Streamlit dashboard connected directly to the Neon PostgreSQL. This dashboards provides an interactive business insights, including the the overview. This is the business overview over here, and you also see the next tab, the sellers and delivery and review tab. So if you look on to the business overview, the total orders on is 96,478, and with that orders it generates around this revenue, and this is the average order value, and this is the average review score, and this is the on time rate for this. And this is an and this dashboard contains multiple dynamic visualization which are going to see in the next, including the revenue trends, seller analytics, payment analysis, and delivery performance insights. We also implemented the the interactive widgets over here, like date slides. Like if I see this is going to if you can see, this is running over here, and this is going to generate monthly revenue trend from this date to this date. So oh yeah, it is. So This is an implemented interactive widgets that we can dynamically export the data. And we have breakdown of the order status here that tells us the whether the order is delivered, shipped, cancelled, unavailable, invoice pre-processing, created or approved. We also have the different types of payment method for each of the orders, where either it is being used in the credit card or any other type of payment, a voucher, debit card. Everything has been enlisted here. So going with the next sellers tab. So this sellers tab just takes picks out the top 10 states by the revenue and just lists out here. This is the states listed here, and this is the revenue listed in the horizontal. And it just the average review score, colored by the average review score over here. And if you see the summary of the state for each state, it just states the number of orders, number of revenue, and the average review. The next says about the delivery performance and the review analysis. As it this dashboard, we mentioned it have multiple visualizations, right? So this is the review score distribution, where we have the number of reviews over here, and the scores for the reviews has been given out here. That is being you know being the highest in the green, and the color shades for the different. And if you note here, the on time versus late deliveries, the on time has been highlighted more here, because we can say that we can observe that online on time deliveries receive significantly higher customer review scores compared to the late deliveries. So for this deployment, we just configure the GitHub integration with the render to enable the continuous deployment whenever the change is pushed to the repository. Having said that, whenever the change is pushed to a repository, we also, with the help of the CI/CD deployment, we used to check this. So we check whenever GitHub attains any changes, it automatically validate and test the project whenever the changes are pushed. So with this, the application is publicly deployed on the render with the continuous deployment. This is the live deployment of the render that is enabled through the GitHub integration. Okay, so in this conclusion, the project demonstrates the complete end-to-end modern engineering life cycle with like from the raw data ingestion to the cloud hosted data analytics visualization. So everything has been arranged in the GitHub repositories, and the respective images, tables, files, and the YouTube links for the demo videos has been edited in the readme file. That is for this project. Thank you.